average value of a function from a to b, and also how to work out problems on definite integrals. So let's start. If y equal to fx is integrable on the closed interval ab, average value of f from a to b is defined as 1 by b minus a integral a to b fx dx. So 1 by b minus a integral a to b fx dx is the average value of f from a to b. So let's start with a question. Find the average value. Find the average value of y equal to square root of 4 minus x squared for the semicircle on the closed interval minus 2 to 2. So let's start with the solution. This is minus 2 to 2, and this is the upper part of the semicircle, y equal to square root of 4 minus x squared. So your average value, what is the formula for the average value? 1 by b minus a. So it becomes 1 by 2 minus minus 2, that is 1 by 4, integral a to b, integral minus 2 to 2, root 4 minus x squared dx, and integrating, you will get the answer as pi by 2. I'm assuming that you know the formula for integral root a squared minus x squared. If not, you can refer to my earlier videos on YouTube. Okay, now coming to the next question. Supposing we have this function here, and this is the graph of fx, this is a, and this is b, this is p to q. So this is the point a comma fa, and this is the point b comma fb, and then this is the point a. So the question goes something like this. Given capital F dash x equal to fx, the first question is identify f of b minus f of a. So looking at this figure, f of b minus f of a is nothing but this distance. So this is QA. The second part is identify fb minus fa by b minus a. So this is nothing but the formula for the slope. So your answer will be nothing but the slope of PQ, because slope is y1 minus y2 by x1 minus x2. The third part is evaluate FB minus FA. So the solution would be FB will be integral b to x ft dt, because f dash x is fx. So fx will be integral over fx. So fb will be integral b to x ft dt. Fa, what will that be? Integral a to x ft dt. So that would be integral a to b ft dt. And this is nothing but area of this shaded region here. Okay, next question is evaluate fb minus fa by b minus a. So this will be by a formula, the average value, that is 1 by b minus a. What is fb minus fa? We just saw it is integral a to b ft dt. This is a solution that I am doing here of the d part. And this is nothing but the average value of f over the closed interval ab. So that brings us to an end of this question. Let's start with the next question. Again, you have a graph here, and you have A and B here, and you have this bounded region. This is A and this is B. This is the graph y equal to gx. This is g of A, and this is g of b. So given g dash x equal to gx, the first part will be identify g of b. Now coming to the solution, g of b will be g dash b, and g dash b is d dx of gx at x equal to b. And by our definition, this is nothing but the slope of gx at b. Okay, the second part will be evaluate integral a to b gx dx. So coming to the solution, integral a to b gx dx will be nothing but area of this shaded portion. This is area of the shaded portion here, which I have marked in the figure. Okay, now the third part is evaluate integral a to b small gx dx. Now we are given that gx equal to g dash x. So integral of gx will be nothing but gb minus ga. And looking at the figure, this is nothing but the length of AB, the chord AB. This is the length of the chord AB. This is the solution here. Coming to the fourth part, evaluate integral a to b gx dx by b minus a. So the solution would be, this is gb minus ga by b minus a. Again, this is ga and gb. So gb minus ga by b minus a is nothing but the slope of AB. This is your solution. Okay, coming to the next question. Evaluate integral 0 to root 3 x dx by root 4 minus x squared. So we make a substitution here. Put root 4 minus x squared as t. So what will be 4 minus x squared? It will be t squared. So x dx will be minus t dt. Now what do we have to do? We have to change the limits. When x is 0, t becomes square root of 4, which is 2. And when x is root 3, what will t be? 4 minus 3, which is 1. So your integral reduces to integral 2 to 1 minus t dt by t. And in minus integral a to b is integral b to a when you remove the minus sign. So this becomes integral 1 to 2 of dt. The t gets cancelled. So this is t within the limits 1 to 2 and your answer is 2. Okay, let's go to the next question. Evaluate integral minus 3 to 3 dx by 9 plus x squared. So this is of the form 1. Integral a to b, integral dx by a squared plus x squared will be 1 by a. So it is 1 by 3 here. Tan inverse x by 3. Within the limits minus 3 to 3. So that would be 1 by 3 tan inverse 1 minus tan inverse of minus 1. What is tan inverse 1? It is pi by 4. Now tan inverse minus x is minus tan inverse x. So it becomes plus tan inverse 1, which is pi by 4 again. So you will get 1 by 3 into pi by 2. And your answer would reduce to pi by 6. Let's move on to the next question. Evaluate integral 0 to 1 x e raised to x squared dx. So we make a substitution, put x squared as t. So we get x dx, 2x dx equal to dt, or x dx is dt by 2. So when x is 0, what is t? T is 0. When x is 1, t becomes 1. So this becomes integral 0 to 1 e raised to t dt by 2. And that will be 1 by t integral 0 to 1 e raised to t dt. What is integral e raised to t? E raised to t. So this is e raised to t within the limit 0 to 1, which is half e raised to 1 minus e raised to 0 is 1. So this is your answer. Let's do one more question and then we'll conclude for today. If x equal to 2 sine theta, evaluate integral 1 to 2 root 4 minus x squared by x dx. So x is 2 sine theta, so what will be dx? 2 cos theta d theta. So change the limits. When x is 1, sine theta becomes half. When is sine theta half? When theta is 30 or pi by 6. When x is 2, sine theta becomes 1. And when is sine theta 1? When theta is pi by 2. So your integral reduces to integral pi by 6 to pi by 2 root 4 minus 4 sine square theta by 2 sine theta 2 cos theta d theta. So 2 gets cancelled and this will be, you can take out the square root of 4, which is 2. Integral pi by 6 to pi by 2 root of 1 minus sine square theta is cos square theta, and root of that is cos theta. So cos theta into cos theta, you will get cos square theta by sine theta d theta. So this is of the form twice integral pi by 6 to pi by 2 cos theta by sine theta is cot theta, and 1 by, and then you get cot theta and you get a, okay, so we can make a substitution here again. We can put sine theta, cos theta as, so when you integrate it, how will you integrate it? You can write cos square theta as 1 minus sine square theta. So this becomes twice integral pi by 6 to pi by 2 1 minus sine square theta by sine theta d theta. And that would be twice integral pi by 6 to pi by 2 1 by sine theta, which is cosec theta, and sine square theta by sine theta will give you sine theta d theta. So we have twice integral of cosec theta is log mod cosec theta minus cot theta, minus integral of sine theta is plus cos theta within the limits pi by 6 to pi by 2. Integral of sec theta is, integral of cosec theta is log mod sine theta. So this will be twice log sine pi by 2 plus cos pi by 2 minus log mod sine pi by 6 minus cos pi by 6. Sine pi by 2 is 1, log 1 is 0, cos pi by 2 is 0, and sine pi by 6 is sine 30. Sine 30 is half. So you get minus log half, minus cos pi by 6 is cos 30, which is root 3 by 2. So you can further simplify this and write it as minus log 1 minus log 2 minus root 3 by 2. Log 1 is 0, so you will get 2 log 2 minus root 3. This would be your answer. So we have learned how to calculate the